Hello students, I hope you are fine and doing well in your studies. Students, today we are going to start a new chapter, Complex Number and Quadratic Equation. In this chapter, first of all, we will study complex number and after then we will study quadratic equation. So students, let's start with the chapter itself.
Students, in this chapter, first of all, we are going to study what is the imaginary number. Square root of a negative number is called imaginary number. While solving the equation x square plus 1 is equal to 0, a quantity square root of minus 1 is obtained and is denoted by iota, which is imaginary. Further, minus 2 within a square root is an imaginary number and can be written as root 2 into square root of minus 1. The value of this is iota and you can write minus 2 square root is equal to root 2 iota. So students, if a is less than 0, then square root of a can be written as mod of a within a square root times iota. Means if it is root of minus 6, then you can write it is root 6 iota and so on. Students, to deal with iota, we are going to study integral power of iota. As we know, iota is root of minus 1, so we can find iota square is minus 1, iota cube is minus iota, and iota 4 is 1, and this is the main part. For n belongs to natural number, we can write iota to power 4n plus 1 is equal to iota, because iota to power 4n plus 1 can be written as iota to power 4n into iota to power 1, and as we know iota 4 is 1, means you can write it is iota to 4 whole power n into iota, means it is 1, and remaining portion is only iota. So you can write iota to power 4n plus 1 is equal to iota, and similarly iota to power 4n plus 2 is equal to minus 1, because it is equivalent to iota square, that is minus 1, and iota to power 4n plus 3 is equivalent to iota cube, it is minus iota, and iota to power 4n is equal to 1, which is equivalent to iota to power 4. Thus, any integral power of iota can be expressed as plus minus 1 or plus minus iota. In other words, you can say iota to power n, if n is even integer, then it is equal to minus 1 to power n by 2, and if n is odd integer, then it is equal to minus 1 to power n minus 1 by 2. And as we know, we can write iota to power minus n is equal to 1 upon iota to power n. Students, here are some questions we have to evaluate. Iota to power 786. As we know, 786 is the 4n plus 2 type system. Means iota to power 4n plus 2 is equal to iota square. Then we can say iota to power 786 is equal to iota square. The value is minus 1. Question number 2. It is written as minus iota to power 23. And as we know, it is minus 1 to power 23 into iota to power 23. And iota to power 23 is the 4n plus 3 factor. Means you can write iota to power 23 is equivalent to iota cube, and the value of iota cube is minus iota, and minus 1 to power 23 is minus 1. So you can write it is minus 1 into minus iota. Your answer is iota. Means question number 2, simplest form is the iota, and question number 1, simplest form is the minus 1. And here, as we know, iota square is minus 1, iota cube is the minus iota, iota to power 4 is 1, and iota to power 5 is iota whole upon iota. Iota square is minus 1 and iota cube is minus iota. Now we are going to solve it. Minus 1 and plus 1 cancel out, and minus iota and plus iota is also cancel out. It is 0 upon minus 1. That's why the answer is 0. Means simplest form of this expression is 0. One important note is here, root a into root b is equal to root ab is true if at least one of a and b is non-negative. If a is less than 0 and b is less than 0, then you can write root a into root b is equal to minus times of root ab. For example, the value of minus 2 into minus 3 is equal to minus root 6, because as we know, this is written as root 2 iota and this is equal to the root 3 iota, and if we solve it, then it will become root 6 iota square, and the value of iota square is minus 1. So your answer is minus root 6. Now student, here is the basic of complex number. The formal addition a plus iota b, where a comma b belongs to real number, and the collection of all such expression is called the set of complex numbers. For the complex number z is equal to a plus iota b, a is called the real part of z and is denoted by real z, while b is called the imaginary part of z and is denoted by imaginary z. For example, if z is equal to 3 plus 4 iota, then real z is equal to 3 and imaginary z is equal to 4. Set of complex number is denoted by C, which includes the set of all real numbers. Means you can say a real number is the subset of complex number. A complex number z is said to be purely real if its imaginary part is 0, and is said to be purely imaginary if its real part is 0. The complex number 0 plus iota 0 is equal to 0 is both purely real and purely imaginary. All purely imaginary number except 0 are imaginary numbers, but an imaginary number may or may not be purely imaginary. For example, 4 plus 3 iota is imaginary but not purely imaginary. It will be purely imaginary if you can write the example like this: 3 iota means the real part of this system will be 0. Students, what is the equality of the complex number? Two complex number a plus iota b and c plus iota d are said to be equal if a is equal to c, means real part is equal to real part of that number and imaginary part is equal to imaginary part of the second number. The corresponding real and imaginary part are equal. If a plus iota b is c1 and c plus iota d is c2, then either c1 equal to c2 or c1 not equal to c2. What is the meaning of this? Means equality can exist, either they are equal or they are not equal. For imaginary numbers, the property of order is not defined because iota is neither positive nor 0 or nor negative. So c1 greater than c2 or c2 greater than c1 is meaningful till b and d both are equal to 0. Means if b and d are 0, then a and c are comparable, and if b and d are not equal to 0, then c1 greater than c2 or c1 less than c2 are meaningless things. Means complex number is never be comparable. On the basis of equality of the complex number, we are going to study square root of a complex number. Let z is equal to x plus iota b be a complex number such that square root of x plus iota b is equal to a plus iota b, where x and y are the real number. Then you can write square root of x plus iota y is equal to a plus iota b. Now squaring this, it will become a plus iota b whole square is equal to x plus iota y. Now square this, then we can find a square minus b square plus 2ab iota is equal to x plus iota y. On equating real and imaginary parts, we can obtain x is equal to a square minus b square and y is equal to 2ab. Now solving first and second, we can find a is equal to this and b is equal to this. If we substitute the value of a and b here, then we can obtain the square root of a complex number x plus iota y. So we can also memorize the formula that within a root x plus iota y or we can say square root of x plus iota y is equal to plus minus mod z plus x upon 2 plus iota within a square root mod z minus x upon 2 for y is greater than 0. And if y is less than 0, then it is plus minus within a square root mod z plus x by 2 minus iota within a square root z minus x by 2. Means difference is this, here is the plus iota and here is the minus iota. Students, let's see one example. Find the square root of 8 minus 15 iota. As we are observing, b is less than 0 because b is equal to minus 15. So we can find the square root of 8 minus 15 iota. It is equal to plus minus mod z plus a whole upon 2 within a square root minus iota times it is mod z minus a upon 2. Now simplify it. It is plus minus. What is the value of mod z? Mod z is square root of 8 square plus 15 square. It is equal to 64 plus 225 is equal to 289, and it is the square root of 17, means it is 17 plus 8 whole upon 2 minus iota. It is 17 minus 8 upon 2. Now simplify it. It is plus minus. It is root 25 upon 2 minus iota, and it is 9 upon 2. Now simplify it. It is plus minus 1 by root 2 is a common factor. It is 5 minus 3 iota. Means square root of 8 minus 15 iota is equal to plus minus 1 by root 2, 5 minus 3 iota. This is our answer. Students, what is the algebra of a complex number? As we know, in the algebra, we study addition, subtraction, multiplication and division. In the case of complex number, addition of complex number is like this. We have to add real part of first complex number to real part of second, and imaginary part of first to imaginary part of second. And similarly, subtraction takes place. Multiplication of two complex number is simple multiplication of two brackets. Means it is a multiplied by c, then ac, a multiplied with id, then iota ad, and iota b is multiplied by c is iota bc, and iota b is multiplied iota d, it is iota square bd, and simplify the value of iota square is minus 1. We can write ac minus bd plus iota ad plus bc. And division of complex number can be obtained by multiplying the conjugate of c plus iota d, means c minus iota d in numerator and denominator. Like this, it is a plus iota b upon c plus iota d, then multiply it c minus iota d upon c minus iota d. Numerator and denominator can be solved out. It is c square plus d square, because iota square is minus 1. It is ac, and it is a plus bd, and plus iota time we can find bc minus ad. So you can write the complex number is equal to ac plus bd upon c square plus d square plus iota times bc minus ad whole upon c square plus d square. Means you can write, if somebody asked you what is the real part of a complex number, a plus iota b upon c plus iota d, then you can write real part is equal to ac plus bd whole upon c square plus d square, and imaginary part of this complex number a plus iota b upon c plus iota d can be written as BC minus AD whole upon C square plus D square. It is the algebra of complex number. Students, now we are going to study two most important things. First, modulus, and second, argument of a complex number. We define modulus of a complex number z is equal to x plus iota y to be the real number within a square root x square plus y square and denoted it by mod of z. It may be noted that mod of z is greater than or equal to 0. And if mod z is 0, what is the meaning of this? X and y separately must be 0, and it will happen if it is 0 plus iota 0 means complex number z is the 0. In this figure, the mod of the complex number is represented by the line OP. If z is equal to x plus iota y, then angle theta, this angle theta is given by tan theta is equal to y upon x, is said to be the argument or amplitude of the complex number z and is denoted by ARG, means argument of z or amplitude of the z. In case of x is equal to 0, if x is 0, then argument z, either it is plus pi by 2 and minus pi by 2 depending upon y is greater than 0 and y is less than 0. And the complex number is called the purely imaginary complex number. Why purely imaginary? Because the real part is 0, means complex number is like this. It is iota y. Depending upon y, we can write argument plus pi by 2 or minus pi by 2, but the complex number is purely imaginary. So here we can understand the basic of modulus and argument of a complex number. Now, third most important things, conjugate of a complex number. For z is equal to a plus iota b, its conjugate is defined as z bar is equal to a minus iota b. Here the complex conjugate is obtained just by changing sign of iota. Means if z is equal to 3 plus 4 iota, then conjugate of z is represented by z bar and it is obtained by changing iota y minus iota, means it will be 3 minus 4 iota. This is the conjugate of the complex number 3 plus 4 iota. If z is equal to 3 minus 4 iota, then conjugate of z is equal to z bar and it is equal to 3 plus 4 iota. If complex number z is equal to 2, then the conjugate of z is equal to 2 is equal to z bar is equal to 2, because there is no iota, so there is no difference between z and z bar. If z is equal to 3 iota, then you can write z bar is equal to minus 3 iota. If z is equal to minus 4 iota, then z bar can be written as 4 iota. This is the basic of conjugate of a complex number. Now students, we are going to study properties of the conjugate. First property is the z bar whole bar is equal to z. What is the meaning of this? Let z is equal to a plus iota b. Then as we know, z bar is equal to a minus iota b. Then what is the value of z bar whole bar? It is equal to a minus iota b whole bar and is equal to a plus iota b, and which is equal to z. Students, property number 2 is z is equal to z bar. Where it happens? If z is equal to z bar, then remember it, z is purely real. If z is equal to 2, then as we know, z bar is also equal to 2, and you can say z is equal to z bar, then z is the purely real number. Property number 3, z plus z bar is equal to, let z is equal to a plus iota b and z bar is equal to a minus iota b, then what is the value of z plus z bar? It is twice of A, and it is equal to twice of a real part of Z. So you can write a real part of Z is equal to Z plus Z bar whole upon 2. And similarly we can write a real part of Z bar, because real part of Z bar is also A and is equal to Z plus Z bar upon 2, because from here we can find the value of A, and that is equal to Z plus Z bar whole upon 2. And A is, you can write A as the real part of Z or real part of Z bar. Property number 4 is here. Z minus Z bar is equal to 2 iota imaginary Z. We can write here Z is equal to A plus iota B, then Z bar is equal to A minus iota B, and solve it. Z minus Z bar is equal to 2 iota B. Then you can find B is equal to Z minus Z bar upon 2 iota, and B is called the imaginary part of Z. Then we can write imaginary part of Z is Z minus Z bar upon 2 iota. Here it is mentioned. Property number 5, if Z is equal to minus of Z bar, then Z is purely imaginary number. Let Z is equal to 3 iota. Then what is the value of Z bar? Z bar is minus 3 iota. You can put the value of 3 iota here. It is equal to minus of Z. Then we can say that if Z is equal to minus Z bar, then Z is a purely imaginary number. Property number 6 is here. Z1 plus minus Z2 is equal to Z1 plus minus Z2, means whole conjugate can be separated out to the individual complex number. Means let Z1 is equal to A plus iota B, or we can write it is A1 plus iota B1, and Z2 is equal to A2 plus iota B2. What is the value of Z1 conjugate? It is A1 minus iota B1, and Z2 conjugate, it is A2 minus iota B2. What is the value of Z1 plus Z2? It is A1 plus A2 plus iota times B1 plus B2. What is the conjugate of Z1 plus Z2? It is equal to A1 plus A2 minus iota B1 plus B2. Now simplify it. It is A1 minus iota B1 plus A2 minus iota B2. We can write it is Z1 bar plus Z2 bar. And similarly, for difference of complex number, we can also prove it. Property number 7 is here. Z1 into Z2 whole conjugate is equal to Z1 conjugate into Z2 conjugate, and you can generalize it also, and you can write if Z1, Z2, Z3 and so on up to Zn whole conjugate, it is equal to Z1 conjugate, Z2 conjugate, Z3 conjugate into Zn conjugate. Now we are going to prove it. Let Z1 is equal to A plus iota B, and Z2 is equal to, means it is A1 plus iota B1, and it is A2 plus iota B2. What is the value of Z1 into Z2? It is A1 A2 minus B1 B2 plus iota times A2 B1 plus A1 B2, and we can write Z1 into Z2 is equal to A1 A2 minus B1 B2, it is a real part, plus iota A2 B1 plus A1 B2. Now what is the value of Z1 conjugate? It is equal to A1 minus iota B1, and Z2 conjugate, or we can say Z2 bar, is equal to A2 minus iota B2. Now multiply it, Z1 bar into Z2 bar, it is equal to A1 A2, and it is minus B1 B2, and here it is minus times, or you can say, if we are going to write here plus, then it is plus iota. And what is here? If plus iota, then it is a minus a1 b2, and it is minus a2 b1. So we can simplify it. It will become a1 a2 minus b1 b2 minus iota a1 b2 plus a2 b1. As we know, z1 z2 is here. What is the value of z1 z2 conjugate? It is equal to a1 a2 minus b1 b2, and iota is replaced by minus iota here. It is the minus iota a2 b1 plus a1 b2, and we can observe it that this is equal to this, means you can say z1 z2 whole bar is equal to z1 bar into z2 bar. And now we can generalize it also. And similarly, we can prove the property number 8, that z1 upon z2 whole conjugate is equal to z1 conjugate upon z2 conjugate, and it is given that z2 is not equal to 0. Property number 9 is here. Z to power n whole conjugate is equal to z conjugate to power n. Property number 10 is here. Z1 into Z2 conjugate plus Z1 conjugate into Z2 is equal to 2 times real Z1 conjugate into Z2, or you can write 2 real Z1 Z2 bar. How we can find it? Let's take Z1 is equal to A1 plus iota B1 and Z2 is equal to A2 plus iota B2. What is the value of Z1 Z2 bar? Means Z2 bar, here you can write it is A2 minus iota B2, and Z1 bar here it is A1 minus iota B1. Now we are going to find the value of this, means Z1 multiplied by Z2 bar, it is A1 A2, and it is minus minus plus B1 B2, and it is plus iota A2 B1 minus B2 A1. This is the value of Z1 Z2 bar, and Z1 bar into Z2 is equal to A1 A2, and it is again plus B1 B2 and plus iota, it is B2 A1 minus it is B1 A2. We are going to add these two equations, means Z1 Z2 bar plus Z1 bar Z2, it is equal to twice of A1 A2 plus B1 B2, and you can write this is as real part of this, because it is also a complex number and it is the real part and it is imaginary part. And after adding these two equations, means equation number first and equation number second, we find that this is equal to twice of A1 A2 plus B1 B2. So you can write it is twice of real part of Z1 Z2 bar, and it is also equal to twice of real part of Z1 bar Z2. Property number 11 is here. If Z is equal to F Z1, then Z bar is equal to F Z1 bar. This is one of the most important property which can be used in various questions.